We all know that airflow tasks usually run in the workers. So here we are trying to make a wild assumption that what if we can completely remove workers for certain tasks as of now? And of course, the what if stuff is from the Marvel theories. And let me introduce myself a bit. I'm Wei, and I work for Astronomer. And I'm a new commuter just joined the team this year. So yesterday I was mentioned and they asked me to stand up. I already stand behind. So I guess I just cannot stand even higher. And also first time speaker at Airflow Summit. And there's GitHub and linking how you can connect with me. And unfortunately, this Python code doesn't actually run. And because my slide would show some source code. So you can scan this QR code for the slide deck if you want to follow along. So yeah, let's start with how a typical task works now. So that's basically how you define a DAG and how you define a task in a DAG. So yeah, a DAG definition and a task. And because we are going to share a different kind of way how you can define an operator. So if you see this mark, this means we are running the operator in a traditional way. And under the hook, we are actually running the execute method in the best operator in this case. And if everything works fine, head up, the task just success. And under the hook, schedule, when you define the DAG and the task, the schedule and the task is executed, scheduler will change the task instant state, and the worker will pick it up and run the execute method. And after that, if everything works fine, then it will change the task instance state back to success. So that's how a typical DAG works. And since Airflow 2.2, we introduced deferrable operator. So, but why do we need it anyway? So this is an example of a traditional one. In this example, suppose we are submitting Spark jobs to a Spark cluster. We do the submit API call, and then we keep calling the job status of that Spark job, and then we will do some logic after we get the Spark job. But if we are not doing anything, all the stuff will be executing the worker, and a worker slot will be located for this task. But if you're using deferrable operator, then you still need to run part of the logic in the worker because we probably don't have an async version of the submit or change logic. So we still need to submit the job in the worker. But afterward, we can defer the task from worker to the trigger, and trigger will pull the Spark cluster job status asynchronously, so it does not actually occupy a worker slot. And after we get the job status, it will come back to the scheduler, and scheduler will assign the worker to run the remaining logic. So that's the deferrable operator stuff. And if you see the sign, this means this page is for deferrable operator. But yeah, release slot, and so what? It actually means you can reduce the resource usage, which also means cost saving potentially. So yeah, this is how deferrable operator work under the hook. And at first, this operator still run the execute method. So we're still doing the same thing. The scheduler changes status into queued, and the worker just run the execute method. And when it goes down to this line, this is what the traditional operator different from deferrable operator. So if the self.defer function, which is divided in best operator. So under the hook, it's raise a task defer exception. And you also need to define what's the trigger you are going to run this async task. So, and under the hook, the worker run the execute method, raise the exception, and will change the task instance to deferred. So that trigger will know that I will need to pick up this job and run this task asynchronously. And this is the trigger we just defined here. the S3 key unchanged S3 key unchanged trigger. So the trigger will run the async version of the run method here. And if everything works fine or everything does not work fine, but when this task ended, it will yield a trigger event, and this event will be sent back to the scheduler. So at this moment, after we run the method, yield the event, and we'll change the task instance state back to scheduler again, and scheduler will try to run the next method of this operator. It doesn't necessarily need to be execute complete, but yeah, most of the time we just set it as execute complete for this kind of deferrable operator. So under the hook, the scheduler pick up, read the QD status, and it will the scheduler change the task into QD status, and another worker just pick it up and run the next method, and then go back to the worker with the that either it's the SAS or value. Yep, but actually not every operator or sensor really needs to start from the worker first, because in this example, the execute method only do the deferrable flag check and also the poke. But the poke stuff is actually can actually be executed in the in the trigger as well. So yeah, we probably just don't need to run it first. So what can we do? We actually can simplify the step here. So the step here is that we QD and run the execute method, which does not run many logic before deferring and defer blah blah blah. What if we can just rest task defer exception in the scheduler and change the state to defer directly, and then let the trigger pick up the task and just run the async method and return what it should return. So yeah, when you see this sign, this means this is the feature, a new feature that we are going to talk about. So yeah, this is an example of how we start a task execution in the worker, just the standard the standard deferrable operator. And this is how we need to define for a task that can be executed directly from the trigger. So here you'll need to let airflow know we want to run this task directly from trigger using this flag start from trigger. And another thing is that start trigger args. You'll need to define the trigger you actually want to run, the keyword args, the next method after the trigger finish its execution. So that's how it defined. And when you compare the new way of definition with the original deferrable operator self-defer stuff, you can see they're pretty much similar. Here, we define the trigger class, it's time delta trigger, and the keywords we pass into the trigger class in the next method, which usually just execute complete. And actually, we still can define these two arguments in self-defer, but they come with default values. And here, you don't necessarily need to define. I just want to showcase. You can configure it if you want to. Most of the time, they are just not. Yeah. And under the hook, this is how scheduler decide where we want to directly schedule this task into a worker or change it to deferred so that trigger can pick up. And this code is something folks from behind can see. So I try to visualize it a bit. So the basically this is what the scheduler used to do. It will check where this task is inherited from an empty operator, and if it's so, it does not allocate and worker to run it because it doesn't need to. It just mark it as the task directly, and if not, it will mark it as a schedulable task, and the worker will then pick it up. But now, we are adding an additional condition, which is check whether start from trigger is true. And if this task does not inherit from an empty operator, then we'll check this flag. And if so, we'll defer this task directly from the trigger and later from the scheduler, and later the trigger will just pick it up. If not, then yeah, it's just like the normal task. So that's basically how the task execution in the trigger stuff works. We simplify the steps a bit upfront, but what if we don't even need to run the next method in the worker? Like this one. Yeah, it already said that we have nothing to do here, so we can just mark the task as complete. So it doesn't really make sense that you need to you finish your task in the trigger and go back to the worker, go back to the scheduler and allocate another worker to, hey, this SQ complete, this just does nothing. So yeah, you don't actually need to do this step. So we probably can simplify this step as well. So if everything works fine, then we can just change the task instance state to success or whatever it should be in the trigger. So yeah, let's still go back to how standard deferrable operator works. So it's in execute method, you still try to defer this task into an existing trigger, and then the trigger finish its execution and go back to this execute complete method and run it in the worker. And here, this is the trigger we are using for this example. And if we want to end the task execution, this time we are not going to change anything in the sensor or operator side. We'll directly change the trigger. In this case, we are using time delta trigger, which inherits from bedtime trigger. And this is the logic we added here. And yeah, let's run it a bit. So previously, we said that we need to yield a trigger event after all the execution in the trigger object. And now we can yield a task success event directly. And actually, we now suppose three kind of different batch task and event. If you want to end this task in the trigger, then you can just yield a success event, failed event, or skip event, and the trigger will know what's that we need to change. And under the hook, this is how the trigger job done. So basically, it just submit the event which we yield in our trigger code, and running the bit, the submit event stuff just use this handle event, and it change the jobs. It change the task instance step here, which is provided by the batch task and event. And it used to be set this way because they always say to be scheduled. So after the trigger finish, we still need to go back to the worker. But now we change it to it can be success, failure, whatever. It just ended in a trigger. And actually, this feature is implemented by MKit. And we already know this new feature, but what does this mean to a DAG author? I would say you'll be able to release more worker slots. So yeah, hence you don't really need to use that much resource and probably some code saving as well. And you can improve your operator and sensor efficiency through this new feature. And because it's kind of new, so I believe there will be more use case for this one after more operator author know how to use it. So yeah, for operator author, of course, it's a new feature you can leverage and run your test in an async manner. Or can simplify your execute and execute complete method, which I think is mostly useful for sensors, I think. Yeah. And for Airflow itself, well, it's potentially a way to run all the tasks in async manner, or probably in the future, we can move all the synchronized code into asynchronized stuff. But yeah, not quite sure that something will happen in the future, maybe. And this feature is actually added in Airflow 2.10. And you can find it if you scroll down to the end of the Airflow 2.10 post. There's an additional new feature there. And yep, so for certain operator or sensors, you can just run your task this way. the scheduler just pick the task up and check the start from trigger flag end. And if that's true, it just change the state to deferred and the trigger will run it. And if you yield a fast task end event, then the trigger will just mark the task instance state to like success, failure, or skip. So the whole task won't go into the worker at all. So yep, the circle has now complete and everything just works fine, except for no, it's not. There's still some limitation for both of the features. So for the limitation on the start execution side, it actually only has limited execution, limited support for dynamic test mapping. You'll need to define these two arguments in your init method because the scheduler need to know how to like defer your task when it's dynamically mapped, and that need to be exactly the same name. And also the whole init block will be ignored before the task execution. So the task will directly go to the worker, directly go to the trigger, and you run the async function and then go back to the worker. And the init method is run at that moment. So yeah, this can be quite weird for some tests. And the interface is a bit different from standard dynamic test mapping as well. You need to specify the start from trigger and trigger keyword args here. And other argument doesn't actually mean anything because it directly passes into the trigger. Yeah. If you don't know where you need to use this feature with dynamic test mapping, I would say just don't try it. It's probably not something you want. Yeah. And for the limitation on end execution in the trigger, you actually cannot use it with the listeners. Yeah, if you use listener with the argument end from trigger, Airflow will want you. And I believe it blocks you from doing so. So that's the limitation for this one. And I actually wrote a few blog posts about the start from execution stuff. And I detailed why the dynamic test mapping is implemented that way and why the limitation and how you should use it. So if you are interested, you can scan this QR code. Yep. So this is the last page.